sides, if we come back to this by looking at polygons with equal sides. Sides are equal. So in this case, or in this case, notice the tick marks that I use. I'll put tick marks to indicate equality of sides. So it will be if one side has one tick mark and another side has one in that same figure, then that means that they're equal. There's some undisclosed length. Right? The length doesn't matter, just the relationship that they're the same. But if a polygon has all equal sides, it's called equilateral. And if you have a polygon with all equal angles, it's called equiangular. Okay, and if you have a polygon that is both equilateral plus equiangular, then it's called a regular polygon. And all the angles are equal, then your figure is called a regular polygon. Okay, so can you have a regular triangle? Yeah, a regular triangle is a triangle with 3 equal sides, 3 equal angles. Well, what would the angle measures be in that? They'd each be 60. Okay, and so this is referred to as an equilateral triangle. So even though it's also a regular triangle, we'll generally refer to it as equilateral. It also happens to be equiangular. Is there such a thing as an equal or a regular quadrilateral? A regular quadrilateral has 4 equal angles, 4 equal sides. This is a square. Okay, so that is your regular quadrilateral. So every type of polygon, okay, from 3 sides and on, can be represented as a regular polygon. The higher the number of sides go, the closer that polygon, that regular polygon, begins to look like a circle. And so once you get to like 100, 200 equal sides and equal angle measures.
I got the online class approved for March.
Once it gets to those large number of sides, it begins to resemble a circle. All right. Let's talk really quickly. I want to go into just a little more detail on triangles and then quadrilaterals and talk about some of the other classifications. Let's take a look at how to classify triangles a couple different ways. All right, we can classify triangles beyond just from being a convex polygon by their sides or by their angle measures. When you look to classify by sides, you're either looking at no equal sides, 2 equal sides, or all 3 equal sides. Right. If you have a triangle with no equal sides, that triangle is called scalene. And so to illustrate it, if we just drew in a triangle, 1 tick mark, 2 tick marks, 3 tick marks indicate that you have 3 sides of different lengths. Therefore, you have a scalene triangle. Okay. You can have a triangle with 2 equal sides. So again, 2 tick marks and 1. Okay. Each of these represent a triangle with 2 equal sides. These are called isosceles. And when you're looking at an isosceles triangle, you need to be aware of a couple of terms. The sides that connect to the equal sides are called bases. Which mean the angles at those bases, the angles that are formed where the base and the equal sides intersect are called base angles. And then the point where the two equal sides meet is called the vertex angle. So even though all the points, the intersections of sides are called vertices, or each one is a vertex, the vertex angle of an isosceles triangle refers to that vertex where the two equal sides come together. Okay, and then finally, we already saw up here the triangle with three equal sides is classified as equilateral. And again, it'll just be symbolized with the three equal sides. In this particular case, for a triangle, if a triangle is equilateral, then it's also necessarily equiangular, or which makes it a regular polygon. Okay, coming back just really quickly, again, I want to clarify something just like I did with the definition of circle. Okay, these classifications are not complete quite yet. There's one thing missing, and that one thing is, historically, this is how these figures were classified. Any given triangle would fall into one of these distinct categories, but more contemporary classifications will include, for isosceles, two or more equal sides. Okay, and so we're going to follow that in this class. So an isosceles triangle is any triangle that has two or more equal sides. Okay, so this brings up the question, if I were to give you this figure, okay, would this figure be classified as scalene? Would it be classified as isosceles? Would it be classified as equilateral? No. What if I gave you this figure? Would this be classified as scalene? No. Would it be classified as isosceles? Yes, because it has two or more equal sides. And would it be classified as equilateral? Yeah. So once again, coming down to some of the questions that I ask with that degree of truth or degree of validity type of questions, you need to be able to answer it with respect to this classification. So if I say sometimes, always, or never true, an isosceles triangle is equilateral. Sometimes, right? It can be in this case. It also may not be, like in these two cases. What if I say an equilateral triangle is isosceles? Sometimes, always, or never. An equilateral triangle is always isosceles, right? Because it's always going to have three equal sides, therefore it will always have two or more equal sides. What if I say an isosceles triangle is scalene? Sometimes, always, or never? Never. Okay, so be aware of that, those distinctions, and be prepared for questions that kind of use that guide. Right. The other type of classification for triangles is by angles. So you can have an acute triangle, you can have a right triangle, and you can have an obtuse triangle. Okay. In an acute triangle, how many angles of the triangle are acute? All of them. Okay, so all three acute angles in that triangle. Okay, what about a right triangle? How many acute angles do you have in a right triangle? So you have two acute angles. And what are those two acute angles going to add up to? 90 degrees. Okay, and so how many right angles will you have in a right triangle? Okay, you can only have one right angle. Because if you had two right angles, would there be any degree measurement left for that third angle? No. Because, again, you guys are familiar, the sum of the angles in a triangle is 180. Okay, and so then we can go to obtuse triangle. How many acute angles are there in an obtuse triangle? Again, it'll have two acute angles. And how many obtuse angles? Again, at most, or it has to have just one obtuse angle. Okay.